Hey there, time for day number 20. Let's see what we got. Particle swarm. Suddenly the GPU contacts you asking for help. Someone has asked it to simulate too many particles and it won't be able to finish them all in time during the next frame at this rate. Transmits you a buffer, your puzzle input, listing each particle in order. Each particle provides the x, y, and z coordinates for the particle's position, velocity, and acceleration. Each in the format x, y, z. Each tick, all particles are updated simultaneously. A particle's properties are updated in the following order. Increase the x velocity by the x acceleration. Increase the y velocity by the y acceleration. Increase the z velocity by the z acceleration. Increase the position by the velocity. Because of simultaneous blah blah blah, the GPU would like to know which particle will stay closest in the long term. Measure this using Manhattan distance. For example, suppose you're only given two particles, both of which stay entirely on the x-axis for simplicity. Drawing the current states of particles 0 and 1 in that order with an adjacent number line, blah, blah, blah. Position 3, velocity 2, acceleration minus 1, so on and so on. At this point, particle 1 will never be closer to 0, 0, 0 than particle 0, so in the long run, particle 0 will stay closest. Which particle will stay closest in the long term? Okay. So, intuitively, it feels like the particle with the smallest total acceleration will stay closest, right? And if we're doing Manhattan distance, then so this is actually not going to be coding at first. This is going to be me trying to justify the rationale to myself of day 20 particles.pi. So here's what I'm thinking. And here you're going to see my past as a mathematician because I'm going to be thinking like a mathematician. So let's do the 1D case first. Claim if A0, let's say if absolute A0 is bigger than absolute A1, then there exists a time after which particle 0 is closer to the origin than particle 1. Okay? And so proof. You can see I'm really thinking like a mathematician. Okay? So say particle AI has position xi of t and velocity vi of t has position xi of t and velocity vi of t and acceleration ai of t. And now the acceleration is a constant. Acceleration ai, which is constant, because in this setup, looking at these things, the acceleration never changes. Okay? Then vi of t equals v0 plus ai times t, right? Isn't that what we're saying? The velocity increases by the acceleration, and then the position increases by the velocity. And so here we have to do like an integral, and xi of t equals x0 plus and no, I forgot how to do. So I want to integrate this thing with respect to x plus v0 times t, integrate with respect to t, sorry, plus 0.5 times ai times t squared. Okay? And so in particular, x0 of t equals say x0 plus v0 times t plus, I think I've labeled these wrong, plus 0.5 times a0 times t squared, x1 of t equals x1 plus v1 times t plus 0.5 times a1 times t squared. And as t gets really, really big, this behaves like the first two terms don't matter. 0.5 times ai times t squared. And so the bigger ai is further away. So now in n dimensions, basically the same thing is true in each dimension. So in particular in 3 dimensions, we have that, x, y, z looks like 0.5 times t squared times, ax, ay, az. And so the Manhattan distance is just proportional to the sum of those things. It said Manhattan, right? Where I just sum those up. So so that means that all I really want to do is just find which one of these has the lowest sum of those accelerations. So if I want to parse one of these things, and let's just write. So now let's actually do some coding. Now that I've worked out my math, test input equals. Let me get rid of this. Okay, and what do I want to do? I want to do class XYZ. And I would do name tuple, but I think I want to. Yeah, let me just do name tuple. X int, Y int, Z int. So from typing import named tuple. And then I want a class, and what am I calling this now? A particle, right? Class particle named tuple has a position, which is an XYZ, and a velocity, which is an XYZ, and an acceleration, which is an XYZ. And now I want to def a parse line, which will take a line, which is a string, and it is going to return a particle. And so what am I going to do? I am going to say, and let me def parse a triple, which is call this a triple, which is a string, and that's going to return an XYZ. And I'm going to say a triple is like 1, 2, 3, and so let's say XYZ equals triple, and let's just strip it and replace the opening brackets with nothing and replace the closing brackets with nothing, and then split split on the comma, right? And then I just want to return XYZ, int X, int Y, and int Z, and let's say assert that parse triple of 1 minus 2, 3 equals XYZ of 1 minus 2, 3. And then similarly with the particle, the particle looks like that. And so let's say PVA equals line dot strip dot again split on commas. And then I want to return a particle with position equals parse triple of P, and velocity equals parse triple of V, and acceleration equals parse triple of A. Okay, and now I want to assert, and I don't even need to call this test input. Let's just do assert that parse line of this equals, and what does it equal? It equals the particle with XYZ of minus 317, 1413, 1507, and then with velocity of 19, minus 102, minus 108, and then and that should be an XYZ. And then this might be overkill for the modeling, but you know, it's kind of fun. So minus 3, minus 3. Okay, so let's do IPython and run day 20 particles.py, line 58, because I forgot to put a comma in, and too many values to unpack, expected 3. Yes, that is true, because I want to split on, let's say, a comma space, which I think I have there and not there. So yeah, that's an easy way to get around that. Invalid. So now I need to get rid of the P equal and the A equal. So let's do this, and then I will drop off the first two. So this is getting hackier and hackier by the minute, but say print triple, print X, Y, Z. Because P equals, let's try that, and that works. Okay, good. So I changed my definition of a triple inside, but I didn't change my unit test, so then my unit test failed. Good. So now what I want to do is I want to say and what am I asked? Which particle? And the particle is just 0, 1, 2 with open, and let me save the input as well for day 20. Save link as Evan 2017 day 20 input.text. Okay, so with open day 20 input.text as F, and let me just stick this in a name equals main block, because that's what I've done every other day. lines equals f dot read dot split on new lines, and that should be fine. Particles equals parse line for line in lines, and print min of let me do this. Def Manhattan self to int, return abs x abs self.x plus abs. I think I can add plus abs self.z. And what I can do is I can do min of enumerate particles, and key key equals lambda pair, and what do I want? I want pair 1, which is because when I do enumerate, I'm going to get index and particle, and then I want the particle dot acceleration dot and what do I call it? Manhattan. So let's run this. Not enough values to unpack. Okay, so again, we're running into a data problem. Let's print the line. I guess there's probably an empty line at the end, is my guess. There's an empty line at the end. For line in lines if line.strip. So let me do that, and I think that will fix it. And so it's saying particle 125 has very little acceleration. That is very little acceleration. So it is definitely going to be the closest to the origin in the long run. So let's say 125. That's the right answer. Return to day 20. Simplify the problem further. GPU would like to remove any particles that collide. Particles collide if their positions ever match. Because particles are updated simultaneously, more than 2 particles can collide at the same time and place. Once particles collide, they are removed and cannot collide with anything else after that tick. Next example, particles 0, 1, and 2 are simultaneously destroyed. The next, how many particles are left after all collisions are resolved? Okay, so there's 2 things going on here. One is we're going to have to write the step function, which I was avoiding writing. And then the second thing is that we're going to have to decide when to stop checking things. And intuitively, I feel like, when do I want to stop checking things? I want to stop checking things when so the one with the biggest acceleration is eventually going to get the biggest velocity, is eventually going to get the biggest position. So I feel like if I were to sort them in that order, once one guy has the biggest position and the biggest velocity and the biggest acceleration, no one's going to catch him, although that's probably actually not true, because he could be going in the wrong direction. So we might have to do that. So let's think about it. Well, let's write the step function while we're thinking about that. So let's do a couple of things. Def step particle is a particle, and that's going to give us a new particle. And so what do I want to do? Increase the x velocity by the x acceleration. So new velocity equals x, let's say velocity equals particle dot velocity, acceleration equals particle dot acceleration, and let's say position equals particle dot position. Wish there was some nice way of destructuring, but it's not. Particles are in the following order: increase the x velocity by the new velocity is an xyz of velocity dot x plus acceleration dot x, velocity dot y plus acceleration dot y, and velocity dot z plus acceleration dot z. And then new position equals, and it's saying we want to increase by the new velocity. So new position equals x, y, z, position dot x plus new velocity dot x, position dot y plus new velocity dot y, and position dot z plus new velocity dot z. And now I want to return a particle with the new position and the new velocity and the old acceleration because it's not changing. So, and I want to I also want to remove collisions. So, and I will take some particles, which is a list of particle, and I'm going to return a new list of particle. And so what I want to do is I want to say position counts, which is going to be a dict from xyz to int equals default dict int, which means I need a default dict from collections import default dict, and then I still don't have a great idea for when we stop doing this, so hopefully something will occur to me as we go. For particle in particles, position counts particle dot position plus equals 1. So we're just going to go through and we're going to count all the positions, and then I'll just return all of the particles, particle for particle in particles, if position on this next line, if position counts particle dot position equals 1. So if there was only one particle in its position, and so now, let me, I should write some tests for this. Test particles equals, so there's this guy, and then there's this guy and this guy. So I'll just do screwing this up. Okay, so I'll give that guy this position, that guy a different position, and then another of the same position, and 190, 12, minus 2, 18, 10, there's 30, there's 32. And what I want to do is that assert that remove collisions test particles equals, and it should just equal this middle guy because he has a different position from the other two. So that's not much of a test, but it's a little bit of a test. Line 76, invalid syntax because I forgot a comma. name list is not defined, so let's import that. Okay, so that seems right. And also for I should really write a test for this step as well. So assert step of so let's think about this guy, and it's going to be another particle, and the acceleration should stay the same. The velocity needs to increase, so this will go by 20, and this will go minus 105, and this will go minus 111. And then these need to increase by the new velocity. So if it increases by 20, it'll be minus 297. And 1413, if it decreases by 105, it'll be 1308. And 1507, if it decreases by 111, that will be 1396. Is that right? So let's run this test, and that seems to work too. Okay. So let's just for x in range 100. Once particles collide, they cannot more than two particles collide. Once particles collide, for x in range 100. So what do I want to do? I want to say particles equals remove collisions particles. Particles equals step particle for particle in particles. And then print, I don't want to call this x, I'll call it I. Print I len particles. So it starts off with 1,000, and it quickly goes down to 461. So, let's run this a little bit longer and see what happens. Keeps going down to 461, which is not to say that it couldn't go down further, but if it does, it doesn't collide for a long time. So being bad people, let's plug 461 and see if it's right or wrong. And if it's wrong, we'll have to be a little bit more clever. But that is the right answer. Okay, so we did not do anything principled here. We just picked a large number and ran it until it stopped going down. I feel sort of guilty about that, but it worked. This number was picked arbitrarily, and we just ran it and saw that the number of particles stopped going down. This is not principled in the slightest, and we feel very bad about ourselves. Okay, but we got the right answer, so that means that we are done. So that wasn't too bad. We used part one. We used a clever mathing through things, and then in part two we were unprincipled and just ran some stuff, and it seems to work. But that worked out pretty well for us today because it means we got a quick one done. So thanks for watching, and as always, find me on Twitter @JoelGrus, and as always, come back for the next one. Thank you.